Right, so we're on August 31st. You should be on Thursday's lesson. I did put these slides in there for you, so if you need to make some sort of PDF or print them off to take your notes on there, that's fine. I am wanting you to turn in notes from this lesson. I think that's really essential, is that you recognize that I'm not asking you to do extra work. Every part of what I'm asking you to do and turn in is what I think is essential. Okay. If I think something's optional, I'll put optional. Otherwise, you should expect this is how you're going to learn best. Okay. So this lesson's on common multiples and least common multiple. You can see that this is kind of an open sourced lesson that I've borrowed here. I'm actually going to upload a video of someone else teaching this same lesson in case you think that I'm confusing and you want to hear somebody else. All right. So today we're going to explain what a common multiple is, what the least common multiple is, and work on being able to find the least common multiple of two numbers. Okay, so here's what you should do first. Okay, so write out these numbers 1 through 26, or maybe you have them on some slides, and then circle all the multiples of 4 on the list. I'll give you a second to do that. So what I'm saying is like this, and then do the next list of 6 also. So pause it for a second and do that. Okay, so you unpause, you should have already done that. So I'm going to go ahead and do all the multiples of 4. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24. Multiples of 6, 6 times 1 is 6, 6 times 2 is 12, times 3 is 18, times 4 is 24. Okay, so what you should notice here is obviously that 4, being you were counting by 4s, there's more of them there. And what you also should notice is that the first number we run into in both lists is going to be 12, although we have 12 and 24. So what we would call is 12 are called common multiples and 24, and then 12 will be the least common multiple, the first one that shows up in both lists. Okay, so first example here. We have a florist can order roses in bunches of 12 and lilies in bunches of 8. Last month, she ordered the same number of roses and lilies. If she ordered no more than 100 of each kind of flower, how many bunches of each could she have ordered? Find all the possible combinations. And what is the smallest number of bunches of roses she could have ordered? What about the smallest number of bunches of lilies? And explain our reasoning. So when it says when we're talking about these two things and how they can be multiplied out and what the smallest number is. Smallest is like least. So then we're going to have the least common multiple is what we're working on here. Okay. So on this particular example, okay, what I'm going to do is I'm going to take, and this is what you need to do. You need to take the roses and they're in bunches of 12. Lilies are in bunches of 8. So I'm going to put roses right here, lilies right here. Then we'll list out the multiples of them up to 100. Okay, so 12 times 1 is 12. Notice I put the first one. That is important because sometimes you can have one that the first one is the one you need. So 12, 24. 12 times 3 is 36. Times 4 is 48. 12 times 5 is 60. 12 times 6 is 72. 12 times 7 is 84. And 12 times 8 is 96. All right, 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. 8 times 6 is 48. 8 times 7 is 56. 8 times 8 is 64. 8 times 9 is 72. 8 times 10 is 80. 8 times 11 is 88. And 8 times 12 is 96. So when you're turning in notes for this, I need you to have these lists there, okay, and what I'm doing. All right. Now, what we're looking for is all the possible combinations of how many bunches she could have gotten. So that means she could have, if she got the same number, she could have gotten 24. She could have gotten 48. There's the 48 there. She also could have gotten, 72. And she could have got 96. Okay. Now, The first question says, if she ordered no more than 100 of each kind of flower, how many bunches of each could she have ordered? So she could have ordered, let's see, two roses, and three lilies, right? She could have also ordered 4 roses, and 6 lilies. Okay. 8 times 6 is 48. Then she could have gotten the roses 6. So 12 times 6 is 72. So we could have 6 roses, and 8 times 9 is 72, 9 lilies. We could have had how many roses to 96? That'd be 12 times 8 is 96. So we could have had 8 roses, and we could have had 12 lilies. Okay, so that's how many bunches of each. So this is 1 bunch, 2 bunch, 3 bunch, 4 bunch, right? So any of these combinations would have worked. So any of those are her possible answers. Okay, now that's the first part of the question. That's question 1. Question 2 says, what is the smallest number of bunches of roses she could have ordered and the smallest number of bunches of lilies? Well, the smallest number of bunches of roses she could have ordered is 2. See right here? Okay, so she could have gotten 2 roses, and 3 lilies is the smallest one, because that would be match up at 24. So that would explain our reasoning, is that would be 24 of both. Okay. And that's the least number we could get. All right. So what we would say here is, in terms of the math terms, that 24, 48, 72, and 96 are all common multiples of 12 and 8. And the least common multiple is 24. But you use that application to see how many bunches of roses and lilies there were. Right? All right. So a common multiple of 2 whole numbers is numbers that appear in the multiples, or when you're multiplying out both of them, as we saw in that last question. All right. So the least common multiple of 6 and 8 is 24. What do you think the term least common multiple means? Okay, so it will be the smallest one that's in both lists. Okay, so the idea there would be 6, 12, 18, 24, 8, 16, 24. Okay, so that's what it means, is it's the first one that is a multiple of both of them. All right, so let's look at the multiples of, for the second one, 10 and 8 that are less than 100. And then we're looking for the least common multiples. Okay, so we're going to do the list. This is the way the list should look right here. This is not optional. This is how you do it. So 10, 20, 30, 40, 50. You can see why getting good at your multiplication is important. We're using it a lot. Keep posting resources like quizzes and things like this. And, I can give you more resources if you need them, but you got to get good at your multiplying. All right, so 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. All right. I could have just kept that from the last one and dragged it down there. That's okay. So 8 times 9 is 72. 8 times 10 is 80. 8 times 11 is 88. And 8 times 12 is 96. So we're looking for the multiples that are multiples of 10 and 8 that are less than 100. So what I like to do a lot of times is look through the bigger numbers list. So I see 40s in both lists. And then the next one is 80. So we could say 40 and 80 are both common multiples of 8 and 10, but the LCM, the least common multiple, smallest number that's in both lists, would be 40. Now notice, here's a common mistake people make. Sometimes if I, in the past, have asked people, what's the LCM, they'll just multiply the two numbers together, right? That finds a common multiple, but not necessarily the least common multiple. Sometimes it is, sometimes it's not. So number 2 here, you saw that was not the least common multiple. Now on number 3, it actually is going to be. So the multiples of 7 and 9 that are less than 100, and then find the least common multiple of 7 and 9. So we're going to list them out: 7 times 1, 7 times 2, like this. All right. Okay, 49, 56, 63, 70, 77. And I wish they had not said to go this far, just like you do, but I'm doing it anyway because we're learning and mastering it. All right, so that gets me through 7 times 14 there. Make that a little smaller. Notability is a pretty cool program. I like to do that. All right, so then 9 times 1 is 9, 18, 27, 36, 45, 54, 63, 72, 81, sorry, 90, and 99. Okay, so what we should notice on this is that the first common multiple is actually going to be 7 times 9 and 9 times 7. So 63 is the least common multiple in this case. But it's not always the two numbers multiplied together, which you see on number 2. All right. So a common multiple of two numbers is the product you get by multiplying each of the two numbers by some whole number. Okay, 30 is a common multiple of 3 and 5 because 3 times 10 is 30 and 5 times 6 is 30. That should say 30 right there. Both of the factors, 10 and 6, are whole numbers. All right. So, all right. And then the common multiples would then be like of 3 and 5 would be 15, 30, 45, 60, 75, every 15. All right. So, what I would do right now is pause it, get these two done, right? And then unpause it to go over. All right. So, the least common multiple of 10 and 20. So, for number 1 on this page, 10, 20. Okay. First multiple of 20 is 20. So then we go 10, 20. The least common multiple of 10 and 20 is 20. That easy. Okay. Don't overthink it. All right. Number 2, 4 and 12. 4, 8, 12. 12. Okay. So what we see here, look at number 3. The previous 2 questions, one number is a multiple of the other. And what you should have noticed about their least common multiple was that it was actually just the bigger number. And that would be true anytime you have the bigger number being a multiple of the smaller one. Okay. All right, so we got one more problem on the practice here. Lynn's uncle is opening a bakery. On the bakery's grand opening day, he plans to give away prizes to the first 50 customers that enter the shop. Every 5th customer will get a free bagel. Every 9th customer will get a free blueberry muffin, and every 12th customer will get a free slice of carrot cake. Yay, we're only doing 50 this time. Okay, so we have 5, we have 9, and we have 12. Oh, wait, we're doing 3? Yeah, we're doing 3. It's okay. So 12, 24, 36, 48, because it just says up to 50. So we have 9, 18, 27, 36, and 45. And then here we're going to have the 5s, right? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Why do we need multiples here? Well, I kind of is actually, I know that we're working on LCM, so I just was going in and doing them. But it's going to ask you where they are in line. So when you're looking for when things line up and match up with things, like the next time something is going to happen, that's when you're going to use multiples in LCM. Okay, so the question is, all right, it's asking us some things here about these lists. So what these lists mean is that every 5 people are getting a bagel. So number 5 gets a bagel, number 10 gets a bagel, number 15 gets a bagel, number 20. So all of these people get bagels. Every 9, they get a blueberry muffin, and every 12 gets carrot cake. Okay, so for example, if we're looking for the first person on here that's going to get all 3, well, we don't have them on here. Okay, we're actually going to have to go way on out to I don't know, much further out than that. 36, 72, 108, maybe like 180 before you get all 3. All right, so let's see what we got. Diego is waiting in line as the 23rd customer. He thinks he should get farther back in line to get a prize. Is he right? If so, how far back should he go to get at least one prize? So he's at 23. So he is before 24, 27, right? So he should move back one spot if he wants carrot cake, because then he would be at 24. He should move 4 spots back if he wants to get the blueberry muffin, and 2 spots back if he wants a bagel. All right. So something like that. All right. That I just explained that. Jada is the 36th customer. Will she get a prize? If so, what prize will she get? All right. So when we look at that, oh, look, Jada is 36. So Jada is getting a blueberry muffin and she's getting carrot cake. Exciting. So is it possible for her to get more than one prize? Yes, because the 36s match up on both of the lists. Okay. How many prizes total will Lynn's uncle give away? Well, let's look at all the list. Okay. So this is 1, 2, 3. Keep counting all the way through. He's giving away 10 bagels before you get to 50. Okay. He's giving away 10 bagels. All right. The muffins he's giving away 5 of, and the cake he's giving away 4. Let me show you what I'm talking about here. So count how many of these multiples are. There's 10. There's 5 of the blueberry muffins, and there's 4 of the carrot cakes. Okay. So that's just something you can do with multiples, even if you're not doing the least common multiple. So total prizes he's giving away, 10 plus 5 is 15 plus 4 is 19. So our answer is actually 19 by counting all the multiples of all the numbers. Okay. All right. So situations where finding least common multiple is helpful. It's when you're lining up some things, right? And seeing the next time something is going to happen. All right. So what I need you to do today is turn in the notes you took from today's lesson. Then there's the 831 LCM practice problems. What I'm wanting you to do is to list out the multiples as I did on all these questions on this lesson. Then turn in those practice problems. Then go back and watch the video explaining the practice problems after you do them. And then I think it would be really good if you resubmit your work after you check it, because then I can see what you did before and after, and that will allow me to give you feedback on what you were confused on if you're confused still after that. All right, let me know if you have any questions.